caves for miles before bursting out to the surface. But that's of little concern as you approach a precipice wondering, is this a good idea? Unlike canyons, which are carved by fast-moving rivers, caves are formed by a subtler but equally effective force. Most limestone caves start when groundwater picks up carbon dioxide in the air and soil. As the mildly acidic water leaks through cracks in the Earth's crust, it dissolves the surrounding rock, leaving pockets, caves. That's how a chamber 300 feet high can be carved from solid stone in less than 1 million years.
Walls are decorated when trickling water deposits dissolved stone to form stalactites, stalagmites, and other flowstone formations. Since the purest water on Earth is found deep in pristine caves, sometimes we use rafts to explore, which cause less contamination than swimming. Cave decorations are as delicate as fine crystal, easily shattered and impossible to repair. That's why good cavers are trained to move gently underground.
When water leaves a residue of minerals, they crystallize and gradually build up to become delicate cave formations. As Hazel and her colleagues in the lab have found, extremophiles are tough.
We suspect that because of the environment in which they live, extremophiles produce potent chemical weapons. If we can isolate these chemical compounds, we can use them in the fight against disease.
Only the hardiest extremophiles could survive deep in the ice of the North Pole. To collect them, Hazel and Nancy have joined an Arctic expedition to Greenland. Greenland's ice cap is massive. If melted, it would raise the world's oceans 18 feet.
When I first saw camp and saw these little tiny specks out in the middle of nowhere, I started thinking, we're going to be here for a while.
The expedition is led by Frenchman Jeannot Lamberton. Jeannot has gone deeper into ice caves than anyone else alive. In summer, melting ice creates raging rivers, which plunge into the caves, cutting them deeper and deeper.
Heat from the sun can weaken the ice. These jumbled blocks were once the roof of a cave, just like the one we're about to venture into. We started early so we wouldn't be inside when the roof collapsed.
Okay.
All is okay. You're honest. Yes. You use your crampons very well.
Once I dropped into the cave, I focused on how awesome it was to be one of the first people to ever see that place. The ice is alive, and you can hear it creak and groan as it all inches very slowly toward the sea.
The ice is a data bank storing centuries of information for the team's glaciologist, Dr. Luc Moreau.
And also the ice is a memory of the climate. You see different layers here. Blue layer represents the summer and white layer represents the winter. So we can calculate the age of the ice here.
The glacier is truly a time capsule. The deeper you go, the more the seasonal layers are compressed. Only 60 feet down, Hazel can collect samples which fell as snow centuries ago.
So far we've found just bunches of different bacteria, gram-negatives, gram-positive, cocci, spirochetes, all kinds of cool-looking stuff. And the thing is, there's not much I can do with them here in the field. The only thing I can do is freeze them down and take them back with me.
The bacteria Hazel wants most lie buried beneath 500 feet of ice. The team cannot descend that deep until there is a 4-day cold snap to stop the flow of water. They soon get their wish.
The other day it was minus 12 centigrade with a wind chill of minus 26 centigrade, which is colder than a freezer. So it was very cold, bitterly cold. Big time. Too cold to be pleasant.
Waiting for the water to freeze up was the hardest part because we're out in the middle of an ice cap. There's not a whole lot to do.
This is definitely a caver's haircut.
To prepare for the deep descent, Nancy has to learn to measure the movement of the ice as the cave walls are slowly pushed in by the tremendous weight of the glacier.
Of the Moulin.
Oh, so from this point to this point is what we measure how it closes.
4 days into the cold snap, Jeannot decided to risk perhaps his deepest descent ever to get samples for Hazel. Only days ago, this was a deadly waterfall. The deeper you go, the more unstable the ice becomes. Jeannot has seen ice boulders burst from the walls like cannon shots. 10-foot spears can break loose without warning. So he purges the walls of loose ice to protect the team members who will follow. Sometimes, to set ice screws in the safest spot, Jeannot turns himself into a human pendulum. Assisting Jeannot on the descent, Luc is concerned about dripping water icing up the rope at 200 feet.
I've rappelled into hundreds of vertical pits around the world, but never anything like this. Ice adds an element of unpredictable risk.
At just over 500 feet, Jeannot grows increasingly concerned about the instability of the ice. This is the second deepest ice cave Jeannot has ever explored.